what do we have going here? We know that a function possesses three critical values, one at -3, one at 0, and one at +3. You know what? I'm going to draw this number line, label it x, and we've got three critical values. One occurs here at -3, the other one at 0, and the other one here at +3. Now we can analyze the second derivative here and use the second derivative test. And the second derivative test says just plug in the critical value into the second derivative and see if we get a positive or negative number. So I'm going to create a little table here. I'm going to say x, f double prime of x, which we are given to be 3 x squared minus 3. So put in -3. So if we put in -3, what do we get? We get 3 and then -3 squared minus 3. So this is going to give us 3 times, what do we get here? 9 minus 3. Now look, all I care about is this positive or negative. This is positive. So this means that it is concave upward. Curve opens like this. Now put in 0. At 0, we're going to get 3 times 0 squared minus 3. That's just going to be 3 times -3, which is negative. That means it's concave down. It opens downward like this. And a +3, I'll put in a +3 here. I'll get 3 squared minus 3. Now, that's 3 times 9 minus 3 is 6. That's going to be positive, which means it's concave upward and opens like this. So what we've got here is a minimum, a maximum, and a minimum. So if I come back to answer my questions up here, select an answer, it says. So I'm going to select minimum, or actually, what should we say? Probably says relative minimum. So let's undo that. I'll say relative minimum, a relative maximum, and a relative minimum.